So supply functions also, supporting functions are more basic ecosystem services, pollination, nutrient cycling. So those regulating functions, we can also put a dollar value to. Supporting functions, incredibly difficult to figure out a dollar value for the nitrogen cycle, etc. So there are some that are still very difficult to value. Cultural functions also, looking at aesthetic, recreational value, we can get dollar values for those. If you have a view property, you're paying for the aesthetic value, and we can establish a dollar value. Spiritual value, who knows how to value, don't put a dollar value to that. So some things are easier to value. How do we look at valuation? Well, we conducted a valuation which we released last year in 2010. We've done many of these now, but we looked at the deltaic area of the Louisiana. This is the area we looked at, the Chenier Plain to the east and the Mississippi Delta. And I'll explain why it's important. But the first step, and it doesn't matter whether you're looking at 1 acre or thousands or millions of acres, we've kind of developed a nice methodology with academics and others. Earth Economics, we're a nonprofit. We just want to get this information out so that it's useful. We want it to be easy, inexpensive, and applicable to your area, to what you're doing. So the first step is really, does this ecosystem service exist? So there's a list of ecosystem services, and we look at the landscape effect. So rivers and lakes, wetlands, riparian forest in Louisiana. We looked at salt marsh, brackish marsh, fresh marsh, cypress swamp, etc. So you could kind of extend those land use types. In fact, each of these biomes or whatever actually provides a huge number of benefits. Wetlands provide biodiversity. They provide flood protection. We need to know how those things are provided. Whoop, I kind of skipped ahead. So this is based on a national database of ecosystem service valuation studies that we have. And we use basically academic peer-reviewed valuation studies with accepted valuations that Army Corps or anybody else accepts them, of avoided cost and such. And each method depends on that ecosystem services. So for flood hazard reduction, the ability to value is very high. For spiritual value, we don't have a methodology. So each ecosystem service has a particular type of valuation methodology that works, and it may be more transferable to other areas or less transferable. Flood hazard risk reduction is sort of relatively transferable. A study in the Puyallup River Basin is pretty good to apply to the Snoqualmie or an area like that. Other things are not very transferable. Well, anyway, so we went through and looked at each ecosystem service in the deltaic area of Louisiana. We established these dollar values for everything from salt marsh all the way up, and then you can kind of add these up across the ecosystem services to get yourself a kind of a dollar per acre of benefits, whether it's for fisheries production, etc. And the end result is you can add this up just like a house appraisal. So if you think about it, this is sort of like how we appraise houses or businesses. We want to know what that natural landscape is providing. And the way we do it is we look at the lowest values in the academic literature and the highest values. And that gives us kind of a boundary that is useful to decision makers. And in Louisiana, the total came to about $12 billion per year in benefits across these ecosystem services, so we can line item out fisheries production, flood protection, etc., and a high of about $47 billion. And just like in 1927, when we didn't even measure the money supply or GDP, now we have a vision of where our natural assets are and how much they provide. Why is that important? Because it shows us that we need to invest in them. And so we look at this ecosystem services just like you'd look at a building. If you're getting a steady stream of, say, $12 billion a year out of that delta, you can calculate back sort of an asset value. Just like if you had a house and you rented it, you could take the rent and calculate back the total value of your house, what you might sell it for. That's the asset value. So the asset value, if we calculated, Only a few of these ecosystem services for the Delta would be about $330 billion to somewhere around $1.3 trillion. That's a lot of asset. That's a lot of value. And to think that we've lost 1.2 million acres thinking that we lost wasteland, that's a big mistake. And if you compare it just to BP's assets, that was about 70 to 120 billion, depending on the value of oil or the sale price of oil. You know, we don't want to threaten an asset that's this big with an asset that's just this big. And then we did a scenario analysis, and I thought Margaret's comment was right on. You know, if we look at that huge asset, this is a critical area for the United States, one of our second largest fisheries areas in the country, etc. And we, whoops, sorry, I went the wrong way there. We calculated aggressive restoration, which is really to look at $15 to $20 billion, large diversions. I mean, this is a great year for the wetlands because we've got all 3 diversions open down there. Incredible amount of sediment. We're probably getting as much sediment as we would get over 25 years just this year. And so this is an opportunity to really restore those wetlands, as well as providing flood benefits and protection. And so we would get about $62 billion of net benefits if we carried out the restoration on the scale that is needed, that academics have identified. Well, that shows that it's worth $15 billion if you're going to get $62 billion net benefits pretty clearly. If we never counted those benefits, then yeah, it's a hard argument to make, spend $15 billion. So another thing I want to talk about is we think about cost-benefit analysis. When it was developed in the 50s, we did not say, let's take an economic methodology of the 20s and see if we can kind of improve it a little bit. Actually, we kind of scrapped all that and we started something brand new. And we used that successfully for decades. Now, let's think about also, so first thing, it's very easy to include ecosystem services in cost-benefit analysis. The levee is worth X amount for hurricane protection. The wetlands are worth X amount for hurricane buffering. Flood protection, we can value levees and dams. We can also value wetlands and forests. We can value agricultural lands, really crucial. And so if you take the Mississippi Basin, we could lay out spatially specific, right down to the acres, you know, where we've got permeable soils that can absorb and recharge our groundwater. That's important for drinking water. It's important for flood risk reduction. We can also map the loss of those benefits. This is a map of tiling. And for each one of those dots, that's 20,000 acres that is being drained straight into the Mississippi River. Well, if we're not paying attention to the fact that we're evacuating this water a lot faster, of course we're going to have greater flood risk. And so we've worked with the National Academy of Science in China. They have an amazing project where above Beijing they decided it was cheaper and better development value, economic development, to pay 40,000 farmers, raise their houses, move them up, and have their agricultural lands as floodway. And as was mentioned here, it actually improves the soil. And those farmers get a payment every month for flood protection. And Beijing was able to have lower levees because now that flood's in the wider area. And what they found is that that doubled the income for rural farmers. And so they've got schools and economic development going into those areas. So agricultural lands are actually viewed as part of the flood protection infrastructure. And this is what we need to do. We need to start looking at our agricultural lands as part of the infrastructure. Otherwise, what we're doing is we're saying, okay, let's tile that last little bit of corn of the worst agricultural lands. We get a marginal benefit out of that for the farmers, but we end up flooding Cedar Rapids as a result because we're sending the water down so quickly. Okay, and then we could also map nitrogen. You know, we have a huge dead zone off the end of Louisiana. These red areas are the primary areas of nitrogen runoff and production. And so we have to think about this in a systems approach. And by mapping both a number of hazards and a number of benefits on the landscape, we can really do our economics better. And we can also straighten out some incorrect economic incentives. So I won't talk too much more about that, but basically each ecosystem service has a different mapping on the landscape. So floods are constrained within a watershed. And aesthetic value is more a view property. Carbon and climate is global. And so we received a National Science Foundation grant to take a look at how you map ecosystem services on the same area, even when they extend, some extend beyond, some are close by. And the important thing about that is that when you look at a watershed, suddenly you realize, wow, this area here, it's providing flood protection. It's important for drinking water. It's important for biodiversity. We're laying these layers of ecosystem service. It's a lahar zone. We don't want people living we have a lot of people living in the lahar zone. But suddenly when you have that view, then that gives you really good instruction for land use planning, for getting the incentives right, for saying mitigation-wise, this is why this particular zone needs to perhaps go into a recreation area. And then we're not going to have people living there being demolished by lahar and floods and other impacts. So this is important because in the 20th century, we did land use planning and we built a great nation on economics which fit the 20th century. And in the 21st century, we need to be aware of this kind of value. So think about this. For flood risk reduction, these three sort of maps. What are our total provisioning assets for flood risk reduction? Well, yes, levees, dams, agricultural lands, forests, wetlands. It extends to the entire watershed is our provisioning assets. Who are the beneficiaries? We can map the beneficiaries. One of the problems we realized in the Northwest in many places is that flood districts jurisdictions are set around where the beneficiaries are and where flooding takes place. And often that does not include the flood provisioning assets. So like in King County, we did a report over King County. We had 6 little flood districts all at the bottom of these watersheds, and all you can do is build levees because that's the jurisdictional limit. And yet the assets that are really providing flood risk reduction are forests and areas. They take the majority of the water, in fact, and permeable soils. So those jurisdictions could not do their job as flood risk reduction because they were not at the scale of the assets that provided. So King County, to their credit, they expanded the flood districts. They merged those 6 and made them watershed wide. And second, how do we map the impairments and dangers? So just as Jim was saying, we need to be able to map flood risk reduction, earthquakes, lahar, all these threats on the landscape, and that gives us a much better idea of how we need to do mitigation. Well, sorry, this is a very poor slide. We actually, in the Chehalis, that's the Pacific Ocean, we looked at how you could model flood protection across the landscape, including forests, wetlands, and such. And it's very exciting that we're going to be able to kind of model that. And I want to say this, that the job of flood risk reduction is incredibly difficult because we don't have all the tools that we need. So for instance, in this watershed, the Chehalis, and every watershed, in fact, we do not have the tools to say, here is the value of your forested landscape, here is the amount of water that is held on and recharged in agricultural lands, here's how much water is quickly sent off agricultural lands into the rivers. And so if we had a modeling system where you could look at both your natural capital and your built capital for flood risk reduction, you could run scenarios of different rainfall patterns and say, is it better for us to try and store more water on the landscape in forests or agricultural lands, or do we need to build these levees higher, or do we need a spillway here where we're going to get benefits to agricultural lands if more fertile soil is placed there? Do we need more sand down the Mississippi because that's going to benefit Louisiana? So we really don't have modeling today which can take into account all of these things. In fact, what we're sort of faced with is cost-benefit analysis that says, well, we've got a positive cost-benefit analysis for a levee on this reach, so let's build it. And it's not a watershed-wide approach. And so in the long run, we need to improve cost-benefit analysis, but we also need to look at what is the next tool where you can spatially know what your risk is, what your benefits are on a number of ecosystem services and a number of threats. So I'm kind of going to wrap up here pretty soon. We can also look at uncertainty, and I think this is a huge, we can map uncertainty. So in other words, when we map flood protection on the landscape, how sure are we that we're getting flood protection out of that asset, you know? Are we definitely sure, 98.9 percentile, or are we sort of sure? And we can start looking at that uncertainty under different scenarios, and that's really important in the future. So I kind of want to wrap up here with, when you understand on the landscape where provisioning of benefits takes place, where the impairments are, where things are being damaged, and who's providing the service, you have all you need for a good funding mechanism. So we can change the way we fund flood risk reduction. And in Washington, we're proposing, it's exciting, in the Green River Valley, we've been working with a number of cities, Seattle up to Black Diamond, and one of the exciting things is that by looking at ecosystem services, it reduces conflict. So for example, we had a levee setback, the North Winds Weir, which was going to be for salmon restoration. And there was a lot of argument about that. Some people said, you know, what are we doing? $2,000 per salmon? This is like a $5 million project. That's crazy. And the Chamber of Commerce didn't like it, and Boeing was a little bit worked up, and the port. And then we said, well, by moving this levee out for salmon restoration and putting these off-channel sloughs in, you get a little flood protection as well. Let's calculate the dollar value of that. And suddenly, the Chamber of Commerce went, we need like 20 more of these salmon projects. And Boeing was in favor, and there was a unanimous vote among people who didn't vote unanimously on much. And I think this is why including ecosystem services is important. And so finally, we've proposed kind of a wild thing. If the 20th century was about one problem, one infrastructure. You want a telephone, put telephone lines in. Stormwater problem, put stormwater pipes in. Flood problem, put levees in. One problem, one infrastructure. Now we realize we need to have a holistic view. 16 cities putting stormwater into the river, that's a problem. You know, because it means higher flood levels, peak floods. So we've proposed kind of merging some tax districts, looking at why can't a flood district pay for the marginal difference for a stormwater district to put their water into the groundwater, which is good for salmon and reduces flood damage. And so a watershed investment district would look at all the capital asset investments within that watershed and say, how can we get better flood protection, salmon restoration, and stormwater, relieving stormwater and drinking water within this watershed by actually seeing how we lay out all these investments. And that hopefully will go to legislation next year. And with that, I just wanted to conclude by saying cost-benefit analysis, we can include it easily. Ecosystem services, we can look at rate of returns on investment. Environmental impact statements, it's the first time we're saying, well, here's a dollar value in environmental impact statement that actually fits with the project, and we can look at economic returns to conservation and restoration. So I think your job is more important all the time. The 21st century is really going to be the century of public goods, such as flood risk reduction, and so I'm glad you're here, and you're doing a greater public service. You're more important in the 21st century than you were even, your services were in the 20th century. Thank you.